All right, chemistry kids, here we go. Unit 5, the mole still going on here. And really what's going on here is we already talked about this one, percent composition. Now we're going to start talking about the next part, which is going to be the last one, element's average atomic mass. Now we did a couple of these calculations earlier, but we didn't really talk in depth about them, so we're going to talk a little bit more in depth and do some more stuff with it. All right, so here we go. Average atomic mass, which is the second part of your notes. So how do I explain the element's average atomic mass? Well, what you got to think of is there's a weighted average and there's a normal average, kind of like a grade. All right, so a weighted averages include the percent abundance. All right, whereas a normal average just it's how many there are and just divide it by that many. Okay, so the percent abundance, think about like your grade. All right, like 25% is labs and 50% is tests and so on and so forth. Okay, so how much each one is worth matters. So what's the general formula for a weighted average? Well, it's going to be something like this. Then you're going to add, and you can keep doing it a bunch of times, and that's going to be your weighted AVG, your average. Okay, so you're going to have how much it's worth. So this would be like your points times the percent abundance times the abundance. Okay, so points times the abundance, and then whatever other categories they have, points times the abundance. All right, and then you can have like about 7 different ones if you really wanted to, but that's kind of the general formula. So there is a weighted average that we use all the time, and the weighted average that we use all the time is on the periodic table. Okay, so on the periodic table, if you notice, all these numbers for the weights are all decimals, and they're all very, very, I guess you could say, detailed decimals, because they're like, to the thousandths, to the hundredths, things like that. All right. The reason why they're decimals, not whole numbers, because they're a weighted average. All right. They're a weighted average of all the different isotopes of that element. All right. So remember, isotopes are when the neutrons change. And when you add neutrons, you add weight, or you take away weight, things like that. All right, so weighted averages, that's what's going on. So find the average of these two elements. Here's how we put this formula right up here into practice. So let's try a calculation with this formula and put it into practice, and so you see how it correlates a little bit. All right, so there are 5 different isotopes of titanium. All right, there's titanium 46, there's titanium 47. So remember, these numbers up here are the weights. Titanium 48, 49, and 50. All right, and next to each of those, the symbols, is the percent that there's actually above. So what is the average atomic mass of titanium? Well, here we go. We have a percent abundance and our point value for that titanium. All right, so let's just go right down the line. Well, one of the isotopes is 46, so 46 times 8%, but remember, we don't times it by 8%, we times it by the decimal form of 8%, so it's going to be 0.08. Add that to the next isotope, 47. Well, how much is the 47? Well, it's 7.8%, which is 0.078 in decimal form. Then we do the next isotope, 48. 48 times, and this is 73.4, so it's going to be 0.734 plus 49 over here, which is 5.5%, so 49 times 0.055. All right, and let's see, we're running out of room here, but we'll get there. Plus element isotope 50, which is 0.053%. Okay, so there's my whole setup. Here's isotope 1, 2, 3, 4, 5. Here's the point value for each isotope, or the weight. Here's the percent abundance for each isotope, and you just times and you add, times and you add, times and you add, and you add them all together, and that's your average. All right. So you could do this in steps, or you could do this in one big calculation on your calculator. It depends how you set it up. All right, so if we go 46 I'm just going to do it one big step in my calculator. 46 times 0.08, close the parentheses, plus, open parentheses, 47 times 0.078, close the parentheses, plus, open the parentheses, 48 times 0.734, plus 49 times 0.055, plus 50 times 0.053. There. Push enter, and here is my calculation that I got. 47.923. Alright. So I got 47.923, and remember all of these numbers are here. This is an AMUs, atomic mass units. Alright, and then if we want to, we could round that number to the correct number of sig figs. So we go sig fig answer, we go 2 and 1 and 2 and 1 and so on and so forth. Alright, so actually we probably go 2 if you really wanted to, but we'll get, so sig fig answer, you'd probably say it'd be 48, but we're going to keep this in our decimal form because this is way better, because we want to find the average of this, because there's no real measurements. It took me just calculations. All right, so there is your weighted average for this calculation. Here's the setup for it. All right, so how much it's worth, percent abundance, and add all different isotopes together. All right, let's try a different one. So there's a little longer one. Let's try another one. Here's the next one. This uranium has 3 common isotopes. It has U-234, it has U-235, and it has U-238. All right, and here's the percentage for each one. So what's the average atomic mass? We'll set it up just like we did. Well, we have 234 times the percent, which is 0.01%, which is add 2 zeros, 001, plus 235 times 0.71, so add 2 zeros to that, 0.1271, plus 238, and we have to times that by the percent it was worth, which is 99.2, oops, there would just be 0.9928. Don't get confused by that, sorry about that. Then we just plug in our calculator, and that is our average atomic mass. So this one we should be able to show you a little bit better, because it's not so long. So we go 234, clear that, sorry, parentheses, 234 times 0.0001, close the parentheses, plus 235 times 0.0071, close the parentheses, plus 238 times 0.9928, close the parentheses, and we got 237.9783, and it's going to be AMUs. So it's my average atomic mass for those 3 isotopes of uranium. All right, so again, point value, percent abundance, different isotopes, add them all together, and there's your weighted average. In other words, the weighted average includes the percent abundance, how much of it is going to be there. So obviously this one's closer to 238, all right, to U-238, because 99% of what's out there, of the uranium that's out there, is the uranium-238, so it's going to be close to 238. All right, hope this made a little bit of sense, and we will talk to you guys later.